Hi everyone, thank you so much for joining us today. We have a special guest speaker today, Jing Yu Koh. Jing is a machine learning PhD student at CMU, where he is advised by Professor Daniel Freud and Ruslan Salakhutdinov. He works on grounded language understanding, and his research aims to build machine learning models which can fuse different modalities, text, images, videos, and more. Before joining CMU, he was a research engineer at Google Research, where he worked on text-to-image generation and multimodal deep learning. This work is a recent work which got really famous, and it is basically evaluating multimodal agents on realistic visual web tasks. So thank you so much, Jing, for joining us today, and over to you.
Yeah, thanks a lot, Ahmad, for the introduction and the invitation. So today I'm going to talk about VisualWebArena, which is a paper that we put out recently. I'm very excited about this work and the future of multimodal agents. So I think this talk will be about like 30 to 40 minutes. So feel free to raise your hand or just unmute and ask any questions in the meantime. So yeah. So what are multimodal agents? You can think of this as, in the long term, these will be computer agents that can do any task that a human can do on the computer. So I might ask my agent to help me find a shirt that has this image on it. It should be able to open up Amazon, type in the appropriate search query, and find an item that's similar to what I want. So these type of agents, eventually, hopefully, they will be able to help us do a bunch of different things. And this is like one simple example of what they can do at the moment. So why do we want to develop these autonomous web agents? I think there are several reasons. One thing is that a lot of the productive tasks that we perform in work today can be done on the computer. I think a lot of us do most of our work in front of the computer, and a lot of these tasks are also on the web. So most of my day is spent either in like Jupyter notebooks or Google Slides or Google Sheets. So I spend a lot of time on the web. And I think there's a lot of opportunities for strong agents to automate these tasks. So you might imagine some agent that's able to help you like format your slides or change the text, automate a lot of work that we do on the computer. So these have a huge opportunity to augment human capabilities and make us a lot more productive than we are now. So one example that I really like is setting up AWS. So I often do this like maybe twice a year or 3 times a year, but not frequent enough for me to become familiar with the interface. And I think AWS or like Amazon, compute in general is very difficult for a human to grok. But if you could imagine that you had a strong web agent that could navigate this, set up like whatever EC2 instance you want, change the security group, and just like spit out the IP address for you to SSH into, that would probably save a lot of time for a lot of people. Other platforms that agents could automate include things like B2B services. So for example, I think this is a Salesforce dashboard. It can be pretty confusing for users who aren't familiar with it, but web agents would be able to automate a lot of things that are done on these type of platforms. So I think like web agents are interesting from a research perspective because they don't work very well yet. And WebArena was one approach towards measuring and evaluating these agents on realistic tasks. So WebArena is a POMDP environment that consists of like state, action, observation, and transition pairs. The observations can be HTML web pages, in terms of screenshots, HTML code, or like accessibility trees, which are simplified representations of HTML. You can perform a variety of actions on WebArena. So these are very similar to actions that a human would take on the web. You can click on things, you can hover over elements, you can type in search boxes, or you can press certain keys. Every web environment in WebArena also has a deterministic transition function. So this is just like a complicated way of saying if I click on something on a web page, it will transition to a different page. And what that looks like depends on the exact web environment that you are operating on. And we also have a reward function which determines whether an agent successfully executed a task. So WebArena is very interesting, and I'll have more concrete examples later on of tasks in WebArena-like environments. It's the most realistic web benchmark as of today, in my opinion. So it's like a full-fledged simulator. You can go onto web pages, you can click on the things. They are not static web pages. So it's a full like back-end, front-end, self-hosted system. It contains websites from 4 popular categories, such as a shopping site, a content management site, a Reddit-like forum site, and a GitLab site for code reviews and and things like that. All the environments are self-hosted, so you can reset them, you can do whatever you want in the environment without fearing that your agent will go and do something crazy in the real world. All the data is very realistic, so it's from real environments like Amazon, Reddit, and GitHub. And I think the interesting thing about WebArena is that it's very easy for humans. So humans get about a 78% success rate on WebArena, but it's very difficult for LLM agents today. So even the best models like GPT-4 only get about a success rate of 14% on WebArena. And WebArena is really good, but I think one of the main drawbacks is that it's designed to just use text and HTML source code from the web pages. So if you look at what you have in the WebArena environment, all the tasks are kind of structured around having access to the HTML and having access to the text. So this limits the realism of certain tasks that you can design. It also doesn't really allow us to benchmark multimodal models and multimodal tasks. So some might, say like maybe HTML is sufficient. You can represent most of the things on the web in HTML, and that's possibly true. But I think if you think about like how humans navigate the web and how we like think about things and navigate websites, we don't look at the HTML. We look at the actual visuals of the website. We can like take a screenshot and pretty much like figure out where you want to click and where you want to what you want to do. So HTML. If you look at the HTML code of most web pages, even a fairly simple landing page like Amazon's web page, it's extremely complicated. There's a ton of like HTML, JavaScript, and CSS code to render all the things you see on the web page. And most of it is pretty much like unreadable to humans. It's very hard to grok what's on the web page if you just look at HTML. On more visual websites like Google Sheets or Google Slides, you also can't rely on HTML because it's basically non-existent. All the content that you have in this sheet is not going to be displayed nicely in the HTML. The HTML is mostly like JavaScript and calls to some backend server to render what you see on the page. And Google Slides, which I'm using right now, the HTML source code is also not. You can't use it to understand what's happening on the web page. So there's a lot of drawbacks with just HTML or text-based systems. It's very messy. Usually they are minified or compressed for efficiency. So JavaScript and CSS is usually compressed so that it renders quickly on the client side. A lot of interactive things also don't display the HTML. So if you go on a website and 5 seconds later there's a pop-up on the page, you can't really tell that from the HTML. So the HTML doesn't always represent the current state of the web page that the user or the agent is on. Spatial layout is also difficult to convey in HTML. So things that might be a grid would obviously be more sequential in HTML, and it can be harder to understand what exactly is on a page. Another issue is context length. So with today's models, this is becoming less of an issue, but HTML pages are still very complex. So I think even the Amazon homepage that I've shown earlier is a few 100,000 tokens. So if you paste that into like GPT-4's tokenizer, it just spits out an error. This might be less of an issue in the future, but might also not be the most efficient way to represent things. And I think the most compelling high-level point is that the web is currently designed for human eyes. So when you design a web page, you don't think about how the HTML will look like. The HTML can be super messy, but as long as it renders correctly and it looks nice, that's sufficient for most purposes. So I think in the short term, at least, a general web agent will need to process web pages as humans do, which is through the visual aspects. So towards addressing some of these shortcomings, we propose VisualWebArena, which is a visually grounded multimodal benchmark for tracking the progress of multimodal web agents. So VisualWebArena consists of 3 environments: a classified site, and the Reddit and shopping site for WebArena. It contains about 910 realistic, visually grounded tasks. So all of these require processing images or understanding web page visual content in some capacity. So one example might be you have this image of a cell phone, of an iPhone. You pass it to your agent and you say help me make a post selling this item and navigate to it. Price it at $10 cheaper than the most similar item on the site. So it has to navigate the entire site, find the most similar iPhone, pink iPhone on the site, and price your item at $10 cheaper than that. So it requires a lot of navigation, understanding visual content, and taking actions on the web to achieve certain goals. So I'll show some examples of tasks that we have in VisualWebArena. I think some of them are pretty interesting and compelling. So one example here is buy the cheapest color photo printer and send it to Emily's place as shown in the image. So you could imagine a person taking a photo of several addresses and it just tells an agent like, okay, buy this item and send it to Emily as a birthday gift, right? So what would an agent have to do? It would have to navigate to the printer section on the shopping site. It would have to sort all the items by descending price, and it would have to find the cheapest item that satisfies the criteria. So the cheapest color photo printer. And then it would have to enter the appropriate address and ship the item there. So it requires several steps on navigation, understanding web page content, and also importantly, in this particular case, it requires doing OCR on this upside down image and finding the correct information. Another example that I quite like is, please add to my shopping cart all the items from this page that can connect these two devices. So there's a MacBook and there's an Ethernet cable. And because these ports keep changing, you can never really figure out what are the adapters you need. So the agent has to navigate the site, find all the items that can connect these two devices and add them to the cart. And then a user can probably go into the shopping cart and decide which one they actually want to buy. Or you could also automate this by telling an agent to buy the cheapest one or the one with the highest reviews. Cool. Other set of tasks include chart understanding and cross-site referencing. So this is an example of a task that asks the agent, is an information-seeking task. So it asks the agent what's the 2022 total nominal GDP of the area that produces the most sugarcane in 2021. So it has two sites open. It has Reddit and it has Wikipedia. It has to figure out what's the area that produces the most sugarcane in 2021. So in this case, if you look at 2021, it's actually Asia, and it has to navigate to the Wikipedia page for Asia and find out what's the total nominal GDP of that area. So there's also some tasks that include multi-site navigation and pattern understanding and information gathering. So all of these are pretty complex. There's 910 of these tasks in VisualWebArena distributed across 4 different sites, including Wikipedia. And we also group them by difficulty. So there's both visual difficulty and action difficulty. So visual difficulty is how complex a task is visually. If you need to do OCR or you need to understand complex charts, that's a hard visual task. If you need to navigate through many pages of a web page and perform many actions, that's also a difficult task in the action axis. So navigating 10 or 12 steps to accomplish a task would be considered very difficult for current agents. All of these tasks are automatically evaluated. So we have execution-based eval. When an agent is done with a task, we run an automated reward function to check whether it has accomplished the task. So for example, if the task is add something like what the man is wearing to my wish list, we automatically navigate to the wish list tab of the site and find out whether they added anything that is appropriate for that task. So in this case, it checks whether any of the items are a polo shirt and any of the items are green. So a lot of the evaluations are visually grounded as well. So in this case, we query a VQA model. In other cases, we just check for text on the site. So for this task, navigate to my listing of the white car and change the price to 25K, update the price in the description as well. It navigates to the appropriate page and it checks whether the user has changed 25K to 30K. So all of these are automated, which makes it very nice to evaluate. It's also very concrete because you can just check whether the agent accomplished the task instead of checking whether, checking some generation-based metrics that are a bit more complicated to evaluate. In this case, you just check whether the task was accomplished. Cool. So that's kind of VisualWebArena. It contains 910 tasks of varying difficulties. I'm going to pause a bit for any potential questions before I move on to describing the baseline agents that we run. Cool. So Ahmad.
Okay, so right now when you're talking about multimodal, so
Yeah.
how much is the so does this mean that for a web page there's no HTML being passed to the model? Is it only
Yeah,
the
that's a good
screenshot?
question. That's a good question. So I think at the moment, all of our baselines, and it'll be shown later on, all of our baselines have some form of HTML content. I think it's an open question of whether you can navigate with just screenshots. But I think the way we think about it is even though humans do navigate with just screenshots. There's no reason to like limit agents to this. So if you pass like both visual information and HTML information to the agent, it can do better on certain things. Like it doesn't need to do OCR, right? Because you have the text there. So yeah, I think at the moment, all of the baselines we have, they have both images and HTML.
Yeah, makes sense. Thank you.
Yeah. Cool. So we run a few baseline agents. As you know, as alluded to earlier, there's a version of text-based agents where we provide them with just the HTML or just the accessibility tree. So you can think of the accessibility tree as like a simplified version of HTML, usually meant for visually impaired people and screen readers and things like that. So it's a simplified version of HTML. One version of language model agents just includes using HTML as input. Another version is we introduce like set of marks prompting to the HTML representations. So this is a method developed by researchers from Microsoft. And what they do is, or like what we do in this case is we basically assign a bounding box to every interactable element on the web page. So if I can click on this printer, I assign it a unique ID of 28. The other printer is like 31 and so on. So the agent can just reference these IDs if it wants to click on an item. So this is a more visually grounded representation. And we think it's much more simplified than having just HTML. So our best model uses this set of marks representation. How it works is we take the original web page, we produce the set of marks by executing some simple JavaScript on the page. So everything that you can click on, it extracts that, it creates a bounding box, and it adds these to the screenshots. Yeah, and we also provide the text content of every interactable element. So as you know, kind of discussed earlier, you don't really just want the visual content if you also have the text content. So for every set of mark element, we also like add the HTML text content and provide this as input to the multimodal model. And of course, we also provide the task. So sometimes the task includes images. So you provide the image and also the task description, like I'm trying to find this post, navigate to the comment section for it. The agent takes all these things, the web page, the text content of the web page, the task, and it outputs the next action that it wants to take. So it might be like click 31, or it might be type something in tree, for example. So I think the bad news for most people is that these agents are still terrible. But the good news for researchers is that there's a lot of headroom to be made on this benchmark. So even the best model, even the best multimodal agent, which is the set of marks agent, gets about 19% success rate on this benchmark. But human performance is much higher at about 90%. So if we look at like various models, there are text-based models, as I mentioned earlier. So if you look at GPT-4 with the accessibility tree input, again, this is kind of like simplified HTML. It gets quite a bad success rate on this task, so about 7%. If you augment the HTML with image captioning models, so for example, you take Blip2 and you caption every image on the site, you augment the accessibility tree with that, and you feed this augmented representation into GPT-4. It gets slightly better, about 12.75%. If you, in addition, provide the screenshot of the page so that the model has reference to whatever is on the page, it gets like even better at 15%. And lastly, if you like instead provide the set of marks representation, so you allow it to reference those bounding boxes rather than the HTML elements, it gets quite a bit better at 16%. And the interesting thing is that it gets a lot better on Reddit and classifieds, which are more visually dense sites. So these sites are a bit more complex. There's a lot of elements that overlap with each other. And we think that the set of marks representation allows the model to navigate the website a lot more efficiently. All these models, do increasingly better as you provide multimodal information, which makes sense as VisualWebArena is a multimodal benchmark. But I think the interesting thing to note is that all of these models are still like way below human performance. So GPT-4V with set of marks gets about 16%, and human performance is 88.7%. Yeah. And the reason human performance is not like 100% is because of usually some careless mistakes. So people might read a task that says like, buy this item and ship it to Emily Cooper, and they would, go through all the steps, they would add it to the cart, and they would be like, okay, I'm done. But actually they haven't actually bought the item. So there's a bunch of mistakes like this where they miss out like one or two key steps in the task. There's also other tasks where actually you need to search the website for a very long time. So you need to basically do exhaustive search on the website. It would be like find this post and make a comment to the author. So you would have to navigate like through 3 or 4 pages of Reddit and find the appropriate post. And a lot of humans just don't have the patience for that. So these are also one avenue where strong agents could potentially form humans. Yeah. So yeah, some common failure modes of the agents are, it's still pretty bad at long horizon reasoning and planning. It's common for GPT-4 to get stuck in loops, or even like correctly perform certain tasks but end up undoing them because they get confused or something. In terms of the multimodal or computer vision aspects, a lot of the models still have failures in visual processing. So they click on the wrong items. They have trouble identifying like specific items if the web page is too complex. And a lot of these models, as observed by other people, have problems with spatial reasoning. So if you ask for things like what are the prices of products in the first row, or add the second item in the third row to my cart, a lot of the current multimodal models, even GPT-4v, still struggle with this. So I think these are like some common failure modes of existing approaches. Yeah, and I think one of the coolest things about working with agents is that you can like really play with them and you can see what they're doing. So we put out this, and this code is available on our GitHub. So we put out the GPT-4v agent and allow like users to put in any arbitrary task to it. So this task is like navigate to the page of a good Thai restaurant in Pittsburgh. It should have at least 200 reviews and 4.3 stars. Pick the one with the highest rating. So it goes onto Yelp. It searches like Thai restaurant in some area of Pittsburgh, and it scrolls through the listings to find one that has at least 4.3 stars. There's a few here, but it picks the one with the highest rating. So it ends at the suggestion of Pusadi's Garden. So in this case, the model starts on Yelp, but in principle, it could start on any page. So there's a follow-up to this that doesn't start on the specified page. So in this case, it's like make a reservation at Pusadi's Garden for 2 people on the earliest page for dinner. So it starts off at google.com and it searches Pusadi's Garden reservation. It clicks on the first link of the page, which is Resi, which is a pretty good choice. And it tries to find the earliest date that has a dinner reservation. So in this case, it successfully found like February 20th. And it entered my phone number, but it stops here because it sent OTP to a wrong phone number. So the agent can't like do this task. But you could imagine in the future, as they have more and more access to our personal like emails or phones and things like that, they could automate a ton of these things. So you could like get reservations at restaurants that are hard to find reservations for, and do a bunch of other different productive things. Yeah. So I think this was a quick overview of WebArena and how we might build multimodal agents for it. The good or bad news is that state-of-the-art multimodal models like GPT-4v and Gemini still achieve way below human performance. So there's a lot of headroom that we have to make on this benchmark and on other benchmarks before these agents would be generally useful for productive tasks. I think one long-term goal that I'm personally interested in is to automate 90% of computer tasks. And at the moment, while we're benchmarking over things like shopping, Reddit, classified sites, I think in the long run, we really want to be working on productive tasks. So things like Excel sheets, PowerPoint slides, things that will actually help provide economic value to people. And VisualWebArena is, concrete steps towards benchmarking and building multimodal models for this. There's a lot of challenges that we have to solve before we get there. So some include like reasoning over long horizons for models. Applying search and planning methods to language models for improving their performance is also something that I'm very interested in, and a lot of people in the community are also very interested in. I think identifying the appropriate level of abstraction for agents, like whether we are using HTMLs or screenshots or even like API calls, would be an important part of important research area. And of course, we would also need to power these with strong vision, language, and code models. So models that can process images, text, and HTML to output appropriate actions. So I think this is all I have. All the code models and paper is available on our website, jyko.com/VWA. I'm also happy to take any questions for the remaining time, or if you have any questions after this, you can email me. So thanks a lot for your attention.
Thank you for the talk. I have a question.
Yeah.
So when you are evaluating, so did you use like simple LLMs, or there are some agent-specific frameworks like Microsoft has AutoGen, where you have multiple LLMs that perform a single task?
Yeah, that's a great question. So in this work, our focus wasn't developing models. So we mostly benchmark like basic LLMs with prompting approaches. So there are a few short prompts of like 3 examples provided and a bunch of instructions on what the model can and cannot do. So these are like the actions it can take on the web pages, what it should do before like outputting an action. It should reason like step by step. It should say these things. But yeah, we haven't tried any of the more complex prompting approaches like using multiple agents or using like React-based approaches. So yeah, I think that's like very promising for future work. It will probably lift performance by quite a large margin, but I also don't think it will get like it won't be like solved. We still have a lot of work to do, but it will definitely like be a promising thing to try.
Right. Another thing I can think of is that like for many websites, they have like these types of, so I assume that you are using some type of like beautiful soup or Scrappy in the back end to automate the task, right? So I think many
Mm-hmm.
websites have like these kind of blockers where they can sense that if something is automated, so they can like
Yeah.
uh, restrict it at the same time.
Yeah. This is it's a great point, and I think someone also asked in the chat whether it can beat capture. So like one interesting anecdote from when I was testing these models. So when I was getting it to like find the shirt on Amazon, I think it was at the start of the slides. I actually hit a point where I think I was running it too many times. So Amazon like asked me to prove that I'm a human. So I think it gave a captcha and it had the checkbox thing. Or it asked me to pick like the pictures that had traffic lights or something. So I actually didn't like check if the agent could do that. I think in principle, yeah, it's a good point because I guess like one way to think about it is that if you have agents that are close to human performance, it's quite different from repeatedly calling a script or like scraping a website. It's really something that has like control of your computer and it's just like doing things for you. So I think it's maybe a lot harder to detect than typical web scraping sites, typical web scraping. But also there's probably ways to do that. And I think it's also a very interesting research area. Like how do you detect if something is an agent or a human if it's like really using the same controls that a human has. But I think at the moment like sites have ways to identify that you're a bot. So Amazon definitely like could tell that this was an agent and not a human.
Yeah, they use many techniques, like they even see how your mouse is moving, like
Yeah.
if the mouse movement is human like, or is it a complete straight line.
Yeah. So I think at the moment it's pretty obvious to tell, but yeah, it could
Yeah,
be harder, or we will need new techniques. But yeah,
yeah. Thank you.
thanks. Shreyas.
Yep, I had a question. Like, we have seen all of these Chrome extensions that do some kind of basic agent work. You may say, like, be it adding your coupon codes and like some sales or something like that. So,
Yeah.
is there a way your work can be, first of all, integrated into, say, something as simple as a Chrome extension? That is one part. And second, can it augment Chrome extensions by effectively commanding them to do something rather than like trying to get a human click nature kind of a thing?
Yeah, I think that's a great point. So I think this falls under this umbrella of like tool usage that a lot of people in the LLM community are interested in. I think Chrome extensions are definitely a great way to do it. I think for right now that would be a bit difficult for this work because what it has access to is like the web page itself. If you want to use like everything that you have on Chrome and call extensions, you probably need a higher level of abstraction. Like you need to give it access to your entire computer and things like that. But definitely, I think like calling APIs instead of trying to do things yourself. So calling APIs when they're available, right? Like instead of trying to click and search for coupon codes, it applies like the honey extension or something. That's definitely like, it makes a lot of sense, and I think it will be an important part of agents. I think from a research perspective, trying to do everything the way that a human would do, like by clicking and navigating, is also kind of interesting, because that's like the most general way to do things. But we should definitely like try to use APIs or try to use extensions when we can to basically like surpass human performance, right? So I think that's going to be important, but I think at the moment it's hard to integrate Chrome extensions exactly.
Just a quick follow-up question, if you have the time. So the thing is, you were mentioning about it trying to mimic a human kind of a thing, right? So can you not fine-tune, say, some of these smaller language models or whatever language models that can be fine-tuned by you to learn how a human clicks and the way a human moves around in an environment? And maybe, or even throw in a RL agent that kind of guides it on how to be human-like per se. So is that something in your scope of research, or is that something out of scope?
No, I think it's very in scope. I think it's something I'm very interested in. So the reason we did this paper is because we think there wasn't any good benchmark for like multimodal agents. And we think that multimodal agents are going to be important. Like, we probably don't want text-only LLMs in the end. But now that we've built it, I think like fine-tuning these agents on actual human data, it's something I'm very excited about, and other people at CMU and other institutes are also excited about this. I think it's an open question of like how far we can get if we actually fine-tune these models, right? Because GPT-4b like is very strong, but we're just few shot prompting it to do something that presumably it has never seen before in its training data. I would say this is pretty out of distribution of internet data probably. But I think, yeah, fine-tuning is super exciting. I think it will close a bit of the performance that we have here. I think an open question is like how to get this human data. So a lot of the human trajectories that you have on the web are very noisy. Like, humans just do things, and the throughput is very high, right? So for a single like task, you might have like 1 minute of human data, and then you need to figure out like how to segment that into mouth movements and clicks like that. So I think that's like could be potentially challenging to do. There's other data sets like Mind2Web, which are not simulator based, that have human trajectories. So fine-tuning on those could also be a good start. But yeah, I think I'm definitely very excited about this. What you said about small language models would also be, I think, compelling, because in the end, like, so the demos that I had of the agent doing things on the web, they're sped up 3 times because like API calls to GPT-4 is just pretty slow. So I think in the end, we really want like smaller models that we can run locally and have low latency. So yeah, I think basically like all of those things are super interesting, and hopefully we'll see some progress on this this year from the community. Jose?
Thank you for your talk. It was very interesting. So I understood that you said that to compare the performance of this method on different tasks, you mentioned that there's level of abstraction of the task. So my question is if you have some metric for this to know which the level of abstraction of a task or a context, because maybe if you need to compare the performance on a similar task, it has to be the similar level of abstraction. So that is my question, if you have a metric for that, or it's just human intuition.
So I think so we have these like executable reward functions, right, that so these are like human written for every task. So for every task, we get the human to write the evaluation function that would like return 0 or 1 depending on whether they did it. So these are all like the reward functions that we use. In terms of like the level of abstraction, I guess we have these task difficulties. So in the paper, we provide the success rate for every type of task. So if it's visually easy and easy action difficulty, what's the success rate? And this is way higher than like difficult tasks. So we have like the breakdown by sites and by difficulty in the paper. But essentially, like how we evaluate it is with these handwritten reward functions that we just execute on the web pages. So we like grab the HTML, we grab the text, we see if it matches something that a human wrote, and if it does, then we say like correct. If it's wrong, then we say it's a failure. There's some like false positives and false negatives, but overall it seems to work quite well, and it's automated, so it's pretty fast. Yeah, I don't know if that answers your question.
Yeah, yes, thank you very much.
Yeah, thanks for your question.
If we don't have any other question, I think we can end the session here.
Yeah, sounds good. So thanks a lot for your great questions. Again, code models and paper are available on our website. And if you have any further questions after this, feel free to reach out via email.
Yeah, thank you very much. Thank you for that.
Thanks a lot, Ahmad, and everyone. Have a good day.